In this video, we're going to look at topic 33, example 2, use a table to find the product of polynomials. So part A, how is multiplying binomials like multiplying two-digit numbers? What we want to do is multiply the expressions 15 times 18 and x plus 5 times x plus 8 using a table. Now, if we take 15 times 18, you might have seen this written in expanded form, so you may have learned this at some point, which will be 10 plus 5 times 10 plus 8. And what you can do is you can create a table to multiply these numbers. So it's kind of like a Punnett square, if you've ever seen that in terms of biology. But you would create a 2 by 2 grid, something like this. And then we would take the 10 and the 5 and the 10 and the 8 here. So this 10 and 5 go here, and this 10 and 8 went there. Now what you would do is you would multiply into each box. So like this box here would be 10 times 10, which is going to be 100. This box here is 10 times 8, which would be 80. This box is 10 times 5, and this box is 5 times 8. And then what you could do is you could say that 15 times 8 is the same as 100 plus 80 plus 50 plus 40. And that total would be 270. Now, would you always use this method? No, obviously not, especially at a calculator. Or you could use kind of like a vertical multiplication, which you've probably seen before, and we'll talk about when we get to example 4. But this kind of concept can be applied when you're multiplying binomials or polynomials. Doesn't have to just be binomials. So if you have x plus 5 times x plus 8, we can create this chart again, and we can use x, 5, x, and 8. So this x plus 5 went here, and this x plus 8 went here. And now you can multiply into each piece. So in here would be x times x, which we know is x squared. Here is 8 times x, so that would be 8x. Here we have 5 times x, so 5x. And here we have 5 times 8, which is 40. And now we can set it up where x plus 5 times x plus 8 is the same as x squared plus 8x plus 5x plus 40. So these 4 terms here are the numbers that we took from inside. And then combine any like terms that you might have. In this case, we have 8x and 5x. So when we add those up, we get 13x plus 40. So this would be our result when we're multiplying those two polynomials or those two binomials, however you want to look at it. All right, so remember, you can use a table to multiply these. Sometimes some students find this very helpful rather than doing a whole distribution process, but it's up to you. So looking at part B, it says what is the area of the shaded region? The idea is kind of the same thing, right? Here in part A, we created these tables. In part B, they're giving us a figure. So if we look at this group in here, this is 2x times x. So what I'm going to do is I'm going to multiply those. And 2x times x would be 2x squared. Then this piece here is the 2x times the 3. And 2x times 3 would be 6x. And then I'm going to keep going. So this piece in here would be 1 times x. Well, that one's pretty easy. That's just 1x. And then finally, this piece here is the 1 times the 3. 1 times 3 is also quite easy. That's going to be 3. So I now have 4 terms. I have 2x squared plus 6x plus 1x plus 3. Then I can add each of those terms up. If there's any like terms with positive 6x and 1x. So we would say 2x squared plus 7x plus 3. And this would be the area of my shaded region. So although it doesn't look the same, when you're finding the area of a rectangle in this case, it's kind of length times width. So you have the 2x for this piece here. You have 2x times x. Right? That would be the length times the width. I think you'll be okay with this. It's just a series of multiplication. Do be careful with your exponents. When you're multiplying the bases, remember to add the exponents.